We're going to look at factoring in this video. This is section 1.5 of your OpenStax textbook, and these notes are posted on our Brightspace page. Yeah. Okay, so what we're going to start with is greatest common factor and grouping. That's going to be this video, greatest common factor and grouping, and then we'll, in other videos, you'll see working through these other objectives. So greatest common factor, I'm going to kind of assume you know what that is. It's the largest number or the expression with the largest coefficient and most variables, I guess, with the highest exponents. Anyway, that goes into a group of expressions. So I think it's going to be easier if we just look at one. But like, for example, if you have 16 and 20, the largest factor number that goes into 16 and 20 is 4. 2 goes into both 16 and 20, but it's not the biggest number that goes into both of them. 8 goes into 16, but it doesn't go into 20, so it's not common. Okay, and then let's say we throw some x's on there. So we're looking at these two terms, 16x and 20x squared. We already have discussed 4 should be part of it, but now we also want to include an x. So not x squared, because 16x doesn't have an x squared, but they both have an x. So 4x would be the GCF. Okay. So when you're factoring out a GCF, greatest common factor, from a polynomial, first you want to figure out the GCF. And then, so it's basically 1 through 3. And then divide each term by that GCF to see how to factor it out. And then you sort of write it in front with parentheses. So let's, again, just do one, and I think it'll make a little bit more sense. So looking at part A, 6x cubed y cubed plus 45x squared y squared plus 21xy. So one kind of weird thing about this one is that you have more than one variable. And I think this is good for practice, but we're not going to really see that a whole lot with the problems that we're doing. It'll typically just be one variable or either an x or a y kind of thing. Okay, anyway, so what that means though is we need to think about the GCF 3 times. We need to think about it in terms of the coefficients, the numbers, 6, 45, and 21, but then also with the x's and also with the y's to build our GCF. So looking at these 3 terms, 6, 45, and 21, you could maybe sort of just sit there and think about what numbers go into those 6, 45, and 21, but you might maybe do a little factor treeing. So take 6 and write it as stuff that multiplies to 6. It's factors. So you could do 1 and 6, but that's not really helpful. You want to break it down into factors. So 2 times 3. And then 45, you might start with, say, 5 and 9. You might start with 3 and 15. But you want to break it down as much as possible to see exactly what it takes to get to 45. So this is the prime factorization doing this. So we have 5 times 3 times 3. And then finally 21 would be 3 and 7. And those are both prime. And so we can see what's common to all 3 of these is really just a 3. So our GCF is going to have a coefficient of 3. And looks like, looking at all 3 terms, we have just x is common and just a y is common. So x squared or y squared or x cubed or y cubed, like you might be like, well, those are greater exponents, but they wouldn't go into, x cubed doesn't go into 21xy. So what's common is the x and the y. So now we're going to take that 3xy and we're going to think of dividing each of these terms by 3xy. Factoring is really just another way to say division. All right. So looking at each of these terms, and you could take more space to do this, go off to the side. 6 Well, I'm sorry, I'm getting ahead of myself. So let's put that 3xy out front. This is going to be our first factor, and then parentheses, and we're going to write down what we get when we divide each of these terms by 3xy. So 6 divided by 3 is 2. X cubed divided by x, 1x cancels, so we have x squared. And y cubed divided by y would be y squared. And then same kind of thing for our next term, 45 divided by 3 would be 15. You might use a calculator if you're not sure. And it looks like we'll get an xy. And finally, plus 21 divided by 3 is 7. And the x and y both just cancel. So this is our answer. And you can check it by just distributing that 3xy back to the 3 terms in the parentheses to make sure that you get what you started with. So let's do that again with part B. 15x cubed minus 25x squared. So we want to think about what is the largest number that goes into both 15 and 25. And you might just look at that and feel comfortable going, oh, it's 5. But if not, you can think about the factors of 15, 3 times 5, and then 25 is 5 times 5. And you could think of this also, if you wanted to, as 3 times 5 or 5 squared. So it's similar to how we think about the GCF with the x's. So we want to take what's common would be a 5 and just 5, right? Not the 5 squared. 5 squared does not go into 15. So our GCF is going to start with 5, coefficient of 5. And then looking at our x's, looks like the lesser exponent is x squared. So that's what's common. Even though the name is greatest common factor, we're looking for first what's common. So we're going to factor 5x squared out of these two terms. And so I'll do that little trick of putting these over the GCF. And 5x squared is going to go out front because that's what we're factoring out. And then we can think of dividing. So we'll have a 3x minus 5. And again, you can check it by just distributing it back, multiplying it back. So we're doing division, and then you can check it by multiplying. So last one, part C. This one is kind of getting us ready to talk about factoring by grouping. That's the next strategy we'll talk about, or type of factoring. Notice that what's common is actually this parentheses. And looking at what's out front of the parentheses, 6 and x, they don't have anything in common with each other. So our GCF is actually going to be b squared minus a. And if you want, you could put parentheses around it so it looks exactly the same. And so if we put each of these two terms over b squared minus a, and again, if you want, you could do the parentheses around it, we can see like what factor we're going to have left over. So b squared minus a is going to come out front, and it does need a parentheses when you write it factored out. Otherwise, it looks like just the a got factored out. And then we'll have x plus 6. And that is the answer to that one. Okay, so let's look at factoring by grouping. And so factoring by grouping, I've got in these notes, we've got a kind of demonstration here that I'll try to go through. I think it's going to make more sense than trying to read through all this verbiage up here, but it's basically just GCF, GCF, GCF. So you do GCF 3 times and you're done. So one thing though that you have to be careful with is actually how you group your polynomial, or I'm sorry, how you order and then group it really. Typically the order that it's presented to us in is going to be fine, and we're just going to group the first 2 terms and the second 2 terms. So of course that means that we're looking at something with 4 terms. I forgot to talk about that. So this kind of factoring only works when you have 4 terms. Sometimes you can get it to work if you have more than 4, but we're not really going to see that in our class. So you need 4 terms. In contrast, when you're doing GCF, like we were doing up here, it doesn't matter how many terms you have. If there's a GCF, you can factor it out. Okay, so once you've decided how to order your polynomial and chosen your 2 pairs, then you just find GCF of the first pair and then find the GCF of the second pair, and then you'll kind of see the GCF to go from there. So, okay, so let's just do this one. So if we look at xy plus 3y plus 2x plus 6, if you look at just the xy plus 3y, what's common to just those 2 terms would be a y. And so then we can factor y out and we get this. And then we're going to focus on the 2x plus 6, our other pair, our other group. And it looks like with 2x plus 6, what's common would be 2. So we're going to factor 2 out and just let this y parentheses x plus 3 hang out. So when we factor 2 out, we're left with x plus 3. And that is a common factor now. So now we're looking at this as being 2 terms, 2 big terms with common factor x plus 3. So if this is going to work, which it won't necessarily, if you just like write down 4 random terms, it won't necessarily factor by grouping. But if it will, you'll get to this step and you'll have the same thing in parentheses, and that means that it's going to work out. This is now going to be our GCF that comes out front, divides out, and we're left with the 2 original GCFs that we found inside parentheses, so y plus 2. And so that's the answer. And you can check this by multiplying it all back out. Or you might have heard of FOIL. So FOIL is a way to think of multiplying out when you have 2 terms times 2 terms. So let's try example 2. And I encourage you, if you feel, if you've done this before and this is all really familiar, try pausing the video and doing this one on your own and then seeing if you get the same thing as me. Okay, so I think we're going to be okay leaving this polynomial ab plus 7b plus 8a plus 56 in this order, and just group the first 2 and the second 2. So when we group these first 2 terms, ab plus 7b, it's very similar to our example up there. B is common, and that's it. So we're going to factor a b out. I'm going to go ahead and talk about the second 2, 8a and 56. So it looks like 8 goes into both of those because 56 is 8 times 7. So 8 is going to factor out of those 2. So b factors out of the first 2, and we'll be left with a plus 7. And then 8 factors out of the second 2. Make sure you don't drop off that plus sign. That's important, and it can lead you astray if you let that guy drop off. So we have plus 8 parentheses a plus 56. No, that's not right. A plus 7. 56 divided by 8 is 7. And let me just go over here. Now, a plus 7s are the same. What we've got in parentheses is the same. That's our GCF now. And so that can factor out, and we're left with b plus 8. Yay! And you can check it by just multiplying it all back out. All right, so let's try part B. Again, if you want, maybe try doing this one on your own, pausing the video and doing it on your own. So same kind of thing. We're going to sort of just leave it as is and group first 2 and second 2. You might be noticing that the 2 terms in the middle, 3x and the negative 2x, are like terms. You could actually simplify this to be x squared plus x, or 1x, minus 6. But now we don't have 4 terms anymore, so we can't use grouping. So this is kind of setting us up for what we'll learn in the next video about factoring trinomials. This would be a trinomial, 3 terms, how we can get, we'll have to learn how we can get the 3x and the negative 2x. But anyway, don't do this right now. We want to leave it with the 4 terms. So if we group it pair by pair and find our GCFs, x squared and 3x will have x. And then whenever you have a negative in the middle, your GCF is going to be negative on that second pair. So we're going to factor out a negative, looks like 2. So on that second GCF, whatever the sign in the middle is, that's going to be the sign on your GCF. So let's factor x out, and we'll have x plus 3. So this is just coming from the first two. Now we're going to factor out negative 2 or minus 2. And so we'll have x, but now be careful. This is going to turn into a plus 3. So, oh wow, look, it matches. I don't know if y'all can hear my puppy. He's getting into everything while I'm trying to do this video. Okay, x plus 3 is now our GCF. And so we're left with x minus 2 for the other factor. So for part C, think about for part C, if it has a GCF, kind of looks like of all 4 terms. So you always do want to check that. Kind of looks like it might, but actually it doesn't. If you take any 3 terms at a time, it does. You can find a GCF, but if you look at all 4 terms, there's not a single number or x that will go into all 4 terms. So anyway, I'm not real sure why I brought that up, but let's do the same thing. We're going to group first 2 and second 2. So our first 2 terms, 20 and 16, we actually talked about these earlier, have a common factor of 4 and then a single x. So 4x is going to be our GCF there. And then for negative 15x plus 12, we want to do a negative 3, I think, right? Yeah. So factoring 4x out of first 2, 20 divided by 4 would be 5. A single x cancels. And then minus 16x divided by 4x would just be 4. All right, so now we're going to factor negative 3 out. And we should be getting 5x minus 4, but let's actually think about it. So negative 15x divided by negative 3 is positive 5x. And then 12 divided by negative 3 is negative 4. So that works, and we are getting exactly what we should get. So 5x minus 4 is our one factor, and the other one is 4x minus 3. And it doesn't matter what order you write those factors in for any of these problems. Multiplication is commutative, meaning you can switch the factors and still have something equal or equivalent. So this is perfectly fine if, for some reason you end up with that.